On a map of the Earth, the Pacific Ocean occupies a seemingly endless expanse. Its waters cover a vast swathe of the planet, connecting the shores of Asia, Australia, and the Americas. Looking at a globe, it becomes clear that it is home to the largest continuous body of water on Earth. But for a long time, people knew surprisingly little about this ocean. Navigators had crossed it since the Age of Discovery, but everything that happened beneath the keels of their ships remained a complete mystery. For centuries, the ocean represented a frontier for humans. People could navigate its surface, chart routes, and discover islands and continents, but its depths remained inaccessible. Even in the 19th century, when science had already begun actively exploring nature, ocean trenches still seemed almost a fantasy. Scientists understood that the ocean floor must exist, but they had no idea how deep it might be. The first depth measurements were surprisingly simple. Sailors lowered a heavy weight on a long rope into the water. When the weight touched the bottom, the length of the rope could be used to roughly determine the depth. This method was used for centuries and provided only very rough estimates. In some areas of the ocean, the rope had to be unwound for thousands of meters, and sometimes it simply didn't reach the bottom. Gradually, it became clear that the ocean was much deeper than previously thought. In the mid-19th century, the first scientific expeditions began to specifically measure the ocean depths. One of the most famous was the British expedition aboard the HMS Challenger in the 1870s. Scientists aboard this vessel conducted systematic ocean exploration and, for the first time, began compiling more accurate maps of the seafloor. It was then that it became clear that the ocean floor was not a flat surface at all. It turned out to be a complex landscape, reminiscent of land. The bottom contained mountain ranges, deep troughs, vast plains, and underwater volcanoes. But the most amazing part of this underwater world turned out to be the ocean trenches. Some of them extended to depths of several kilometers. Areas of the western Pacific Ocean were particularly deep. Where giant tectonic plates converge, the ocean crust plunges downward, forming enormous faults and trenches. The deepest of them turned out to be the Mariana Trench. It is located in the western Pacific Ocean, near the Mariana Islands. At its deepest point, the depth exceeds 10 kilometers. This location was later named Challenger Deep, in honor of that 19th century scientific expedition. The sheer scale of this depth wasn't immediately realized. Even when scientists first obtained approximate data, they long doubted the accuracy of their measurements. It seemed incredible that a place on Earth existed at such a depth. If the highest mountain on the planet, Everest, were lowered into this depression, its summit would still be underwater. But the problem wasn't just depth. The main obstacle to exploring the ocean trenches was pressure. At the Earth's surface, air pressure is 1 atmosphere. Humans barely notice it, but in water, pressure increases very quickly. At a depth of 10 meters, it roughly doubles. At a depth of 100 meters, the pressure becomes approximately 10 times greater than at the surface. And at a depth of 10 kilometers, the pressure exceeds 1,000 atmospheres. This means that every square centimeter of surface is subject to a force comparable to the weight of a small car. Any ordinary object at such a depth would be instantly destroyed. For a long time, scientists believed life at such depths was impossible. It was assumed that no organisms could survive under such pressure. Furthermore, absolute darkness reigns there. Sunlight ceases to penetrate the water at a depth of approximately 1,000 meters. No one could imagine what the world looks like at a depth of 10 kilometers. Nevertheless, interest in the ocean depths gradually grew. In the first half of the 20th century, new ideas and technologies began to emerge that could change the situation. engineers and scientists began to consider creating vehicles capable of diving to great depths. One of the people who took this task seriously was the Swiss physicist and inventor Auguste Piccard. Piccard was known for his experiments with high-altitude balloon flights. He studied the upper atmosphere and understood the challenges of operating under extreme pressure. His experience proved unexpectedly useful for another task, exploring the deep ocean. Piccard proposed creating a vehicle that could withstand enormous water pressure while safely descending to great depths. This idea led to the development of a new type of underwater vehicle, the bathyscaphe. The bathyscaphe differed from conventional submarines. It consisted of two main parts. The upper part was a huge tank filled with gasoline. Gasoline is lighter than water, so it provided buoyancy. The lower part was a robust spherical capsule containing the people inside. This capsule was made of thick metal and could withstand enormous pressure. The first bathyscaphes allowed humans to descend to depths previously considered unattainable. But the true goal lay much lower. The deepest point of the ocean continued to attract the attention of researchers. Scientists wanted to see the bottom of the Mariana Trench with their own eyes. It seemed almost impossible. However, in the late 1950s, preparations began for an expedition that was to change humanity's understanding of the ocean. The apparatus that was going to be used for this mission was called Trieste. It is in this bathyscaphe that people will descend to a depth of almost 11 kilometers for the first time in history. The story of the bathyscaphe Trieste began long before the famous dive of 1960. It was connected with a man who devoted much of his life to exploring the limits of the possible, Swiss physicist and inventor Auguste Piccard. Piccard was known for his experiments even before he became interested in the ocean depths. In the 1930s, he conducted flights in stratospheric balloons, enormous balloons that rose to altitudes of over 15 kilometers. These flights allowed for the study of the upper atmosphere and cosmic radiation. For such experiments, Piccard developed a pressurized spherical cabin capable of withstanding enormous pressure differences. It was then that he had an idea that would later change ocean exploration. If a sealed sphere can protect people at great heights, where pressure is almost non-existent, then a similar design can also work in the opposite conditions, at depth, where the pressure, on the contrary, becomes colossal. This is how the concept of a new type of deep-sea vehicle was born. In the post-war years, Piccard began working on a bathyscaphe, a vehicle capable of diving to enormous depths. His first project was named FNRS-2. This vehicle became a prototype for future deep-sea vehicles, but serious design problems arose during testing. Nevertheless, the experience proved invaluable. The work continued, and soon a new device appeared, Trieste. The name was not chosen by chance. The bathyscaphe was built with the participation of Italian specialists and was initially based in the city of Trieste. This is where its name comes from. The design of the apparatus was unusual and very different from conventional submarines. The upper part consisted of a huge float filled with gasoline. Gasoline is lighter than water and is virtually incompressible under pressure, so it provided the apparatus with the necessary buoyancy. Beneath this float was a small spherical crew cabin. It was made of steel and had walls over 12 centimeters thick. Inside this sphere were instruments, batteries, an oxygen system, and 2 seats for the crew. The cabin's diameter was just over 2 meters. It was cramped inside, but this compactness allowed the structure to withstand enormous loads. To submerge, the bathyscaphe used ballast, heavy metal weights. When the apparatus was about to descend, the ballast kept it underwater. To surface, the weights were dropped, and a float lifted the apparatus back to the surface. In the early 1950s, Trieste conducted its first test dives in the Mediterranean Sea. Each expedition allowed for greater depth. The submersible gradually proved its design capable of withstanding extreme conditions. The U.S. Navy soon became interested in this project. American specialists realized that the bathyscaphe could become not only a scientific instrument, but also a vital tool for exploring the ocean depths. As a result, the vehicle was purchased by the U.S. Navy and transported to the United States. After this, large-scale modernization began. Engineers reinforced the structure, improved the life support systems, and prepared the submersible for even deeper dives. The main target was the deepest point in the world's oceans, Challenger Deep in the Mariana Trench. The expedition set out for the western Pacific Ocean in the late 1950s. Preparations for the main dive took several months. Every structural element had to be checked, ballast calculated, communication systems tested, and the crew's safety ensured. Any mistake could be fatal. At a depth of 10 kilometers, the pressure exceeds 1,000 atmospheres. This pressure is capable of crushing most metal structures. Even a small crack in the hull could lead to immediate disaster. Despite this, the team continued to prepare. By January 1960, the bathyscaphe was ready for the main test. Jacques Piccard and Walsh were to descend into the apparatus. Piccard represented the scientific side of the project and continued his father's work. Walsh was an American naval officer and an experienced submariner. They knew they were about to undertake a dive that had never been attempted before. On the morning of January 23, 1960, the bathyscaphe Trieste was prepared for descent. The ocean surface was relatively calm, a rare blessing for this region of the Pacific. Piccard and Walsh took their places inside the spherical cabin. The hatch was closed, the systems were checked, and the craft began its slow descent. At first, the immersion occurred almost imperceptibly. The sun's light gradually weakened. The water around the apparatus grew increasingly dark. At a depth of several hundred meters, the last rays of light disappeared completely. Then absolute darkness began. The only source of light was the bathyscaph's searchlights. The apparatus continued to descend. Every minute brought new strain on the hull. Faint sounds could be heard from time to time inside the cabin, metallic clicks and cracks caused by the enormous water pressure. The dive lasted more than 4 hours. As the bathyscaphe approached its maximum depth, a sharp sound was heard. One of the external transparent structural elements had cracked. A loud bang was heard in the cabin. The crew froze for a few seconds. If the crack had spread further, the water pressure could have instantly destroyed the apparatus. But this did not happen. Trieste continued its dive. Soon the instruments showed that the apparatus had reached the bottom. The bathyscaphe touched the surface of the seabed at a depth of almost 10,916 meters. As the apparatus descended, a cloud of silt rose from the bottom. For some time, nothing could be seen through the portholes. Gradually, the water cleared up. The researchers were faced with a landscape that no one had ever seen before. The bottom turned out to be relatively flat and covered with a soft layer of sediment. These sediments formed over millions of years from tiny particles slowly falling through the water. But the most unexpected thing was another observation. Small living organisms were visible at the bottom. This discovery was a significant scientific advance. Many scientists had previously believed that life was impossible at such depths. The enormous pressure and lack of light seemed insurmountable obstacles. However, observations by the Trieste crew showed that life forms exist even here. The bathyscaphe remained at the bottom for about 20 minutes. After that, the decision was made to begin the ascent. The ballast was released, and the craft slowly began to rise. The ascent took several hours. When Trieste finally reached the ocean surface, it became clear that the expedition had been a success. Man has reached the deepest point of the ocean for the first time. This dive became one of the most remarkable achievements of oceanography in the 20th century, demonstrating that even the most extreme regions of the planet can be explored. However, after this historic moment, there was a long pause. Repeating such a dive proved extremely difficult. The technology of the time did not allow for the easy creation of vehicles capable of withstanding the pressure at depths of 10 kilometers. Therefore, for almost half a century after the Trieste expedition, no one returned to the bottom of the Mariana Trench. Only at the beginning of the 21st century did a new expedition again decide to travel into this abyss. And this time the main researcher turned out to be a man known throughout the world as the director of one of the most famous films about the sea. His name was James Cameron. After the submersion of the bathyscaphe Trieste in 1960, it seemed humanity had ushered in a new era of ocean exploration. However, the reality proved more complex. Piccard and Walsh's expedition was an incredible engineering achievement, but it proved extremely difficult to replicate. The Trieste was a unique machine, created for a specific task. Its construction required enormous resources, complex logistics, and extensive preparation. In the following decades, oceanography continued to develop, but deep-sea exploration was more often conducted using unmanned vehicles and research submarines designed for shallower depths. Some of these could dive several kilometers, but they were unable to reach the depths of the Mariana Trench. Interest in the deepest point of the ocean never faded, but for many years it remained more of a scientific dream. The Mariana Trench continued to exist as the ultimate limit of human capabilities. People knew it was there, they knew its depth, but the bottom of this trench once again proved inaccessible. Piccard and Walsh had once descended. The man who took on this challenge was world famous for a completely different reason. His name was associated with the film industry, not oceanography. It was Canadian director James Cameron. Cameron rose to fame thanks to films that became some of the most acclaimed in cinematic history, including Terminator, Aliens, Titanic, and Avatar. However, beyond cinema, he had another passion: deep-sea exploration. Even while working on the film Titanic, Cameron began actively participating in underwater expeditions. For the film, he repeatedly dived to the site of the legendary liner's wreck to a depth of almost 4 kilometers. These expeditions sparked his serious interest in the ocean depths. Over time, this interest evolved into an ambitious scientific project. Cameron decided to repeat the dive to the bottom of the Mariana Trench, but to take it to a new level. He wanted to create a vehicle that could not only deliver a human to the maximum depth, but also allow for comprehensive scientific research. Deep Sea Project began. Challenger. Work on the device lasted several years. Engineers, oceanographers, materials specialists, and research organizations participated in the project. The goal was to create a compact deep-sea vehicle capable of withstanding pressures at depths greater than 10 kilometers. Deep-sea design Challenger was different from the bathyscaphe Trieste. The craft had an elongated, vertical shape. At the bottom was a small, spherical cockpit for the pilot. This cockpit was made of durable material and designed to withstand extreme loads. There was only room for one person inside. Most of the hull was occupied by equipment: high-resolution cameras, scientific instruments, lighting systems, and sample containers. Particular attention was paid to the lighting and filming system. Cameron wanted to not only descend to the ocean floor, but also show the world what the deepest part of the planet looks like. Preparations for the expedition took several years. The apparatus underwent testing, engineers checked the life support systems, and tested cameras and instruments. It was necessary to ensure that Deep-Sea Challenger will be able to withstand pressures 1,000 times greater than atmospheric pressure. Finally, in March 2012, the expedition set off for the Mariana Trench. The dive site was approximately the same location where the bathyscaphe Trieste operated in 1960. The Challenger Area Deep was still considered the deepest point in the ocean. Preparations for the dive took several days, the apparatus was checked, systems were tested, and the support crew prepared the equipment. March 26, 2012 Deep Sea. The Challenger was ready to launch. Unlike the 1960 expedition, this dive was to be solo. There was only one person inside the apparatus, James Cameron. Submersible began to descend. The ocean surface quickly disappeared from view. Challenger moved down significantly faster than the old bathyscaphe Trieste. First the sunlight disappeared, then the water around became completely dark. At a depth of several thousand meters, the pressure already exceeded hundreds of atmospheres. The device continued to descend deeper and deeper. The dive took about 2.5 hours. Finally, the instruments showed that the apparatus had reached the bottom of the Mariana Trench. Deep-Sea Challenger touched the surface at a depth of almost 10,900 meters. There was absolute darkness all around. Spotlights illuminated a small area of the seabed. Cameras began recording the surrounding landscape. The bottom looked different than many researchers expected. It was covered in fine sediment, reminiscent of fine dust. This material had formed over millions of years from microscopic particles that slowly settled through the water column. Despite the extreme conditions, life was discovered again at the bottom. Small organisms adapted to the enormous pressure and complete absence of light were observed. Studying them became one of the expedition's main scientific objectives. Cameron spent several hours at the bottom, collecting soil samples and photographing the surrounding landscape. However, technical problems arose during the mission. Some of the spacecraft's systems began to operate unstable. As a result, the decision was made to end the study ahead of schedule. After this, Deep-Sea Challenger began to climb. The apparatus slowly rose through kilometers of dark water and after several hours reached the surface. This dive marked the second time in history that a human being reached the bottom of the Mariana Trench. Cameron's expedition provided scientists with new data on the geology and biology of the deep ocean. Furthermore, modern cameras allowed them to obtain unique images of the deepest place on Earth. But the story of deep-sea diving did not end there. Several years later, a new expedition set itself an even more ambitious task. Her goal was not just to repeat the dive into the Mariana Trench, but to explore the deepest points of all the planet's oceans. This project was named Five Deeps Expedition. Its initiator was American explorer and entrepreneur Victor Vescovo. Let's continue Project Five Deeps. The expedition began as one of the most ambitious oceanographic programs of modern times. Its goal was unusual and immensely challenging: to reach the deepest points of each of the Earth's 5 oceans. No one had ever attempted such a task in a single expedition. The project was initiated by American explorer and entrepreneur Victor Vescovo. Vescovo was trained as an engineer and financier, but his interests always extended far beyond business. Vescovo was passionate about exploring extreme environments, high mountains, polar regions, and the ocean depths. He had already experienced challenging expeditions and understood that such a project would require not only a scientific team, but also a completely new submersible. The DSV limiting apparatus became the main technical basis of the expedition. Factor. This device was created by Triton Submarines. Its development took several years. Engineers sought to create a deep-sea vehicle that could withstand pressures at depths greater than 10 kilometers and still be reliable enough for repeated dives. Unlike many previous deep-sea vehicles, Limiting Factor was designed as a machine capable of carrying out multiple expeditions. This meant its structure had to be exceptionally robust and resistant to repeated pressure cycles. The main component of the apparatus was once again the spherical crew cabin. It was made of titanium, a metal that combines high strength with comparatively low weight. The sphere had a diameter of approximately 1.5 meters and could withstand the pressures found at depths of over 10 kilometers. Inside the cabin were 3 seats for the crew, control instruments, life support systems, and several windows through which the surrounding environment could be observed. A key feature of the vehicle was its ability to be used repeatedly without lengthy repairs. This was a significant advancement over previous deep-sea vehicles. Expedition 5 Deeps began in 2018. The team planned to sequentially explore the deepest points of all oceans: the Atlantic, Indian, Southern, Arctic, and Pacific. The most challenging part of the project, of course, remained the Mariana Trench. In the spring of 2019, the expedition reached the Challenger region. Deep. This is where the deepest point of the world's oceans was located. Preparations for the dive took several days. The team checked equipment, tested communication systems, and prepared scientific equipment. Simultaneously, depth measurements were taken and the area was surveyed using echo sounders. When everything was ready, the limiting device factor began the dive. The first few hundred meters were relatively calm, the water remained clear, and small fish and jellyfish could be seen through the portholes. But as the submersible sank deeper, the surrounding world gradually disappeared. At a depth of about 1,000 meters, sunlight disappeared completely. Further on began a zone of absolute darkness. The apparatus continued its slow descent. The pressure increased with each passing minute. At a depth of several kilometers, it already exceeded hundreds of atmospheres. However, the limiting design factor operated reliably. The titanium sphere was designed to withstand such loads. The dive lasted several hours. Finally, the instruments showed that the apparatus was approaching its maximum depth. Soon, limiting factor touched the seabed. This happened at a depth of more than 10,900 meters. A cloud of sediment rose again at the bottom, temporarily obscuring the view. When it cleared, a familiar yet still astonishing landscape opened up through the portholes. The floor of the Mariana Trench was found to be covered with a soft layer of silt. This layer consists of tiny particles that slowly settle through the water column over millennia. However, this time the researchers noticed something unexpected. Traces of human presence were found among the sediments. Fragments of plastic waste were discovered at this depth, a disturbing reminder of how widespread ocean pollution has become. In addition, the expedition discovered several species of deep-sea organisms. These creatures were adapted to extreme conditions: enormous pressure, low temperatures, and complete darkness. Scientists collected soil and water samples and also filmed the environment. But the most important result was that the limiting device factor has proven its unique reliability, having dived repeatedly to the ocean's deepest depths. Victor Vescovo personally completed several dives into the Mariana Trench, making him one of the few people in history to reach the bottom of the deepest point of the ocean. Project 5 Deeps concluded in 2019. During the expedition, researchers visited the deepest points of all the planet's oceans. However, exploration of the Mariana Trench did not end there. In recent years, new scientific programs have actively joined the study of the deep sea. One of the most ambitious is the Chinese Deep Sea Exploration Program. As part of this program, a new device was created called Fenduje. This vehicle marked another step in the development of deep-sea diving technologies and made it possible to continue exploring the deepest regions of the Pacific Ocean. China's Deep Ocean Exploration Program began to actively develop in the early 21st century. The country's leadership viewed deep-sea exploration not only as a scientific objective, but also as a strategic direction for technological development. The ocean depths contain vast resources and are of interest to geology, biology, and materials science. Furthermore, the ability to operate at extreme depths requires a high level of engineering, making such projects crucial for the development of scientific infrastructure. One of the first major steps was the development of the Chinese manned deep-sea vehicle Jiaolong. This vehicle was created in the 2000s and was designed to dive to depths of more than 7 kilometers. Tests of the Jiaolong demonstrated China's ability to create complex underwater vehicles and conduct expeditions in the most inaccessible areas of the ocean. However, engineers immediately realized that the next goal would have to be much more ambitious. Fenduje rover, whose name can be translated as striving or fighter, became the true symbol of the new program. Its development took several years and required collaboration between scientific institutes, engineers, and oceanographers. The main goal was to create a manned rover capable of reaching depths of more than 10 kilometers while remaining reliable enough for regular scientific missions. Fenduje's design largely followed the traditions of previous deep-sea vehicles, but also incorporated numerous new technologies. The vehicle's central component was a spherical titanium crew cabin. This sphere was designed to withstand pressures exceeding 1,000 atmospheres. The cabin's diameter was approximately 2 meters, and it accommodated 3 people, a pilot and 2 researchers. Surrounding the cabin were control systems, engines, batteries, manipulators for handling objects on the seabed, and powerful light sources. The apparatus was also equipped with high-resolution cameras and scientific instruments that allowed it to study the geology and biology of the ocean floor. Testing of the device began in the late 2000s. Each dive was part of a complex program designed to test the operation of all systems at extreme depths. In November 2020, Fenduje completed one of the most significant dives in the history of oceanography. The apparatus descended into the Challenger region, deep in the Mariana Trench. There were 3 people on board, a pilot and 2 researchers. Preparations for the dive took several days. The team checked the submersible systems, calibrated instruments, and prepared equipment for collecting samples. When everything was ready, Fenduje began the dive. As with all such missions, the first few hundred meters were fairly uneventful. Surface light and the occasional inhabitants of the upper ocean could still be seen through the portholes. But as the craft descended deeper, the light gradually faded. At a depth of about 1,000 meters, complete darkness fell. The craft then moved through a world without sunlight. The only source of illumination came from powerful spotlights mounted on the craft's body. The dive lasted several hours. The water pressure increased with each passing minute. At a depth of 5 kilometers, it already exceeded 500 atmospheres. Nevertheless, the apparatus's systems operated stably. As Fenduje approached its maximum depth, its instruments read approximately 10,900 meters. This meant the rover had reached the bottom of the Mariana Trench. When the submersible touched the surface, a cloud of sediment rose up around it. This is a common occurrence at such depths. A soft layer of silt covers the bottom, and any movement stirs up particles that remain in the water for some time. When the silt settled, the researchers were left with a landscape that could be described as one of the most extreme places on Earth. The seabed appeared as a vast plain, covered with a thin layer of sediment. This sediment forms over millions of years from microscopic particles that fall through the water column. The researchers used the spacecraft's manipulators to collect soil samples. The cameras also captured images of several species of deep-sea organisms. These creatures are adapted to life under extreme pressure and in complete darkness. The Fendougé dive marked a significant milestone in the exploration of the Mariana Trench, confirming that modern technology allows for complex scientific research at depths previously considered inaccessible. However, not all exploration of the deep ocean requires human presence. In recent decades, unmanned aerial vehicles have begun to play a huge role. These vehicles can descend to extreme depths and conduct long-term research without risk to the crew. One of the most famous vehicles of this type is Kaiko, created by Japanese engineers. Kaiko was a remotely operated vehicle, ROV, connected to the ship via a long cable. It could dive to depths of over 10 kilometers and transmit data in real time. In the late 1990s, Kaiko reached the bottom of the Mariana Trench and conducted a series of scientific studies. It collected soil samples, recorded video, and enabled scientists to gain new insights into life at extreme depths. Later, other devices of this type appeared. One of the most famous was Nereus, developed by the Woods Hole Oceanographic Institution in the United States. This vehicle was unique in that it could operate in two modes, as an autonomous robot and as a remotely controlled vehicle. Nereus dived into the Mariana Trench in 2009 and collected important scientific data. However, in 2014, the vehicle was lost during another expedition when its hull collapsed under the immense water pressure. The loss reminded researchers how dangerous deep-sea exploration remains. Even the most modern technologies are not always able to withstand the conditions that exist at a depth of 10 kilometers. Nevertheless, interest in the ocean depths continues to grow. Each new expedition reveals new details of a world that remains one of the least explored on the planet. Even today, scientists admit that humanity knows more about the surface of the Moon and Mars than about the bottom of the world's oceans. The depths of the Pacific Ocean still hide many secrets, and perhaps future generations of explorers will once again venture into the abyss to see what remains hidden beneath the water. When deep-sea vehicles first reached the bottom of the Mariana Trench, it became clear that the deepest ocean world was completely different from the underwater landscapes seen at shallower depths. In coastal areas and on the continental shelf, the underwater world often resembles land: rocks, coral reefs, underwater canyons, and dense clusters of marine organisms. But at a depth of 10 kilometers, everything looks different. The first impression noted by almost all explorers who find themselves at such depths is the extraordinary silence and stillness of the surrounding space. The water here barely moves. The currents are extremely weak, and any changes occur very slowly. The world of the deep seems almost frozen. The floor of the Mariana Trench is covered with a thick layer of soft sediment. This sediment forms over millions of years. Every day, tiny particles, remnants of microscopic organisms, dust, and mineral particles, slowly sink through the ocean water. These particles are so small that their movement is virtually undetectable. However, over thousands and millions of years, they form a sediment layer several meters thick. When a deep-sea vehicle touches the bottom, a cloud of fine silt rises. This cloud can remain suspended in the water for several minutes before returning to the surface. This is why the first few seconds after landing are often spent in murky water, making it impossible to see anything. When the silt settles, researchers are presented with a landscape that is difficult to compare with anything on the Earth's surface. It's a vast plain receding into darkness. The surface is gently undulating, in places covered by small ridges of sediment. Occasionally, small stones or rock fragments that have slowly slid down the sides of the basin are found. But the main feature of this world remains its absolute darkness. Sunlight cannot penetrate such depths. At a depth of approximately 1,000 meters, the light becomes extremely weak, and below 2,000 meters, complete darkness sets in. At a depth of 10 kilometers, eternal night reigns. The only source of light in these places are the searchlights of underwater vehicles. When beams of light illuminate the bottom, a strange landscape appears before the cameras. A gray-white surface covered in soft sediment, receding into darkness. Sometimes, slowly moving creatures can be seen against this backdrop. For a long time, scientists believed life was impossible at such depths. The immense pressure, low temperatures, and lack of light seemed to preclude the existence of complex organisms. But expeditions have shown that life is capable of adapting to the most extreme conditions. Some of the most common inhabitants of deep-sea areas are small, shrimp-like crustaceans. They can move along the surface of sediments, feeding on organic particles that fall from the upper layers of the ocean. Besides them, various types of worms, sea cucumbers, and other organisms that slowly move along the bottom are found in the depths. Some of these creatures have transparent bodies. Others have soft tissues that allow them to withstand pressure. Scientists have discovered that organisms living at such depths have a unique cellular structure. Their proteins and membranes are adapted to the enormous water pressure. These biological characteristics have become the subject of serious scientific research. Sometimes you can see more unusual creatures at the bottom. Some expeditions have recorded rare fish species capable of living at depths greater than 8 kilometers. Their bodies have an unusual shape and soft structure, allowing them to withstand extreme conditions. These fish move slowly and use energy sparingly. Food is rare at such depths, so most organisms are adapted to a very slow lifestyle. The water temperature in the Mariana Trench also remains very low, typically around 2 degrees Celsius. Despite this, the water doesn't freeze due to the enormous pressure. Sometimes geological structures are discovered on the seafloor, indicating complex processes occurring within the Earth. The slopes of the basin may be covered with cracks and faults. In some places, underwater landslides, huge masses of rock that slowly slide downward, are found. Research has shown that the ocean floor is constantly changing. Although these changes occur very slowly, they play a significant role in the formation of ocean crust. Interestingly, traces of chemical processes related to the planet's internal energy have been discovered in some areas of deep-sea trenches. Water passing through cracks in the rocks can heat up and become saturated with various minerals. These processes create unique conditions in which specialized microorganisms can thrive. These microscopic life forms use chemical energy instead of sunlight. The study of such organisms has become one of the most exciting areas of modern biology. Scientists believe that similar life forms may exist in other parts of the solar system, for example in the subglacial oceans of the moons of Jupiter or Saturn. However, even today, much of the deep-sea world remains unknown. Oceanographers estimate that only a small portion of the ocean floor has been explored in detail. Vast areas of the deep sea remain virtually unexplored. Many trenches, canyons, and seamounts have yet to be explored. Each new expedition brings new discoveries. Sometimes these are new species of organisms. Sometimes they are unknown geological structures. Sometimes they are unexpected traces of human influence on the most remote regions of the ocean. Even at depths of more than 10 kilometers, researchers discovered fragments of plastic and other traces of pollution. This discovery was unexpected and alarming. It demonstrated that human activity impacts even areas of the planet that seemed completely isolated. However, the depths of the Pacific Ocean remain one of the most mysterious places on Earth. Vast expanses of the seabed have never been seen by humans before. And each time the submersible begins its slow descent into darkness, it enters a world that has hardly changed in millions of years. As deep-sea vehicles begin to ascend back to the surface, the first signs of returning to normalcy appear gradually. At first, instruments show a decrease in pressure. Then, the color of the water in the portholes slowly begins to change. The pitch-black, almost opaque darkness of the depths gradually turns dark blue, and then a faint, diffused light appears. This moment always leaves a strong impression on those who participate in deep-sea expeditions. After hours in absolute darkness, even the faintest light seems unusually bright. This is a sign that the submersible is leaving a world hidden beneath the ocean for millions of years. The deepest regions of the ocean exist in conditions that remain virtually unchanged over vast periods of time. Temperatures here remain nearly constant. Light never reaches the bottom. Pressure remains constant and enormous. In this world, there are no familiar cycles of day and night, no winds or waves, no seasonal changes. In some ways, the deep ocean is one of the most stable places on the planet, but it is precisely this stability that makes them so mysterious. On the Earth's surface, everything is constantly changing. Continents shift, climates shift, animal species emerge and disappear. The ocean depths change much more slowly. Sometimes it seems like a separate world, existing by its own laws. When the first explorers began exploring the ocean depths, they expected to find a nearly lifeless space. The immense pressure, cold, and lack of light seemed like conditions in which life could not exist. But expeditions revealed that even here, nature had found ways to adapt. Life at depth develops slowly and cautiously. Organisms conserve energy, move slowly, and exploit any available food sources. Some feed on organic particles that fall from the upper layers of the ocean. Others exploit chemical processes occurring within the rocks. Each new expedition shows how diverse life can be, even in the most extreme conditions. However, the ocean depths are important for more than just biology. They help us understand the processes occurring within the planet itself. Underwater trenches, such as the Mariana Trench, form where tectonic plates collide and one begins to subduct beneath the other. These processes have shaped the Earth's surface over millions of years. By studying such areas, scientists can better understand the causes of earthquakes, the formation of volcanoes, and the movement of continents. Furthermore, deep-sea exploration helps us understand the planet's history. Sediments on the ocean floor gradually accumulate layer upon layer. These layers preserve traces of ancient climates, microscopic remains of organisms, and chemical elements that allow us to reconstruct events of the distant past. Every sample of soil recovered from the ocean floor can contain information about what the climate was like thousands or even millions of years ago. But despite all the advances in science, the ocean remains one of the least explored places on Earth. Modern maps of the seafloor still contain significant gaps. Vast swathes of the ocean have been only roughly explored. In some areas, accurate depth measurements are lacking. oceanographers estimate that much of the world's ocean floor has yet to be directly explored. This means that humanity knows more about the surfaces of the Moon and Mars than about its own ocean. The reason for this is simple. The ocean depths are extremely difficult to access. Sending a probe to a depth of 10 kilometers requires sophisticated equipment, powerful ships, and years of preparation. Even modern materials and technologies are subject to enormous strain in such conditions. Nevertheless, interest in deep-sea exploration continues to grow. Each new expedition brings new discoveries. Sometimes these are new animal species never seen before. Sometimes unusual geological structures or traces of ancient processes. Sometimes exploring the depths reminds us of the fragility of our planet. Even in the most remote areas of the ocean, researchers are finding traces of human activity. Plastic particles, chemical pollutants, and other materials can reach the deepest points of the ocean. These findings are prompting scientists to question the extent to which humanity is impacting the environment. But at the same time, the ocean remains a source of wonder and inspiration. Every dive into the depths reminds us of how vast and complex our planet is. The world beneath the waves remains virtually unknown. It contains landscapes never seen before and organisms yet to be discovered. This is why researchers keep returning to the ocean. Engineers are developing new devices. Scientists are planning new expeditions. Cameras and instruments are again and again descending into the darkness to reveal what lies beneath. The Mariana Trench remains a symbol of this mystery. This is the deepest place on Earth, the point where the ocean reaches its maximum depth and where water pressure exceeds 1,000 atmospheres. Here begins a world that was long completely inaccessible to humans. But even today, decades after the first dive of the bathyscaphe Trieste, this abyss remains almost unexplored. People have only reached its bottom a few times. Vast areas around remain unknown, and perhaps future generations of explorers will be able to see what is still hidden in the darkness at a depth of 10 kilometers, new life forms, unusual geological structures, or phenomena that have not yet been discovered. The ocean depths continue to hold their secrets, and somewhere far beneath the surface of the Pacific Ocean, in a world of eternal darkness and immense pressure, lies one of the last unexplored frontiers of our planet.